Hey YouTube, what's up? This Link. Welcome back to another episode of Coding Session, and we're going to continue our discussion with binary search trees. Obviously, the most common data structure. So, in the last two episodes, the first episode for binary search trees, we did a problem in LeetCode, which is invert a binary tree. I briefly explained the concepts of what a binary tree is, how it's normally structured and whatnot. And the second episode, which I showed you how to create your own binary search tree and search for a specific node within the tree, I showed you how to actually create a binary tree with its own definition, which is, public class tree node, a variable that, or pretty much a variable, or even an instance of an object reference that's going to hold your data, whatever that data may be. And of course, two object references to tree node, which is the left and right pointers to that root's child. And of course, if no child, it's a leaf. Of course, the constructor, you pass your data through, set the data, and initially left and right are null. So I got rid of the search algorithm, but it was a recursive function that used preorder, which you visit the root, the left, and then the right. Today I'm going to go over all three of those orders: in order, preorder, and post order. So definitely recommend you watch the previous two episodes before you move on to this one. So I created a new tree here. Tree is equal to new node 8. And instead of going through this whole left, right, left, and all that, I should show my very beautiful illustration here, just to make it a little bit easier. Okay, I think we can see it. Alright. Oops, that's not what I want. So the root is 8. Then we add 1 to the left. And then we add 2 to left, right. So left, then right. And then we go left with the 0 right here. And then we go right with 10, right left with 9, and right with an 11. And this is also known as a balanced tree. When it comes to unbalanced and balancing trees and rotating trees, that gets a little bit more complicated. I'll try my best to do an episode later on about that, but this is a very basic example of a perfect balanced tree. So, what about the traversal algorithms? So we're going to look in order first. In order, you visit the left first, the left child. Then you go to the root, and then you go towards the right child. And I kind of memorize that as if I'm like climbing the mountain, and I drop off like that. So, and it goes for every single subtree. So 0, 1, 2, then 8, and then 9, 10, 11. So let's just run the code here and we'll see. So, yep, 8, 1, 0. I'm sorry, I'm looking at preorder. I'm sorry. So in order is the second one right here. 0, 1, 2, and then 8, 9, 10, 11. Now if we go over to the preorder, of course you'll notice the base case is if the node is null, that's when it stops, so we can not get into a Stack Overflow and end the recursion. So here's the preorder, which is root, left, right. And you can just think of that as, pretty much you're like scanning down like this in a sense. Actually, it's probably like doing this row by row. That's how I visualize it. And for the preorder, which is the first one here, you can see my cursor, we visit the root first, which is 8. Then we go to the left child, which is 1, then do the left to right, 0, then 2. Then we visit the right subchild, which is 10, or the subtree, the right child of the root. Then we go to 10, then 9, then 11. Postorder is pretty much I want to say the opposite. You can kind of see it as the opposite of preorder, but I want to go ahead and say, oh, this is the opposite of this, and this is the opposite of that. That's going to get confusing. So in order, you just got to remember, in order, you're going left, root, right. Preorder, you're going root, left, right, kind of in order. And then postorder is left, right, then root. And this is more like climbing, because then you go from 0 to the first, you go from 0 to 2, and then to 1, and then you jump to the right, 9 to 11 to 10, and then finally to the root, which is 8. And as we can see here in the post order in the output, 0, then 2, then 1, go to the right, 9, the 11, 10, and then 8. Now again, these are all recursive calls. Of course, the base case, if node is equal to null, return, ends the recursion. And these are very, very simple to code. Once you get the definition of the tree down, and this is just the magical part, is the two tree node object references, the left and the right, allow you to chain nodes together and create this binary search tree for the root to have their childs or not have their childs, so both null, or one of them is null, and they'll be considered a leaf. Well, actually, both of them have to be null in order for it to be a leaf. So, these are the methods to perform these recursions, these recursive methods, algorithms. And of course, you'll see in many examples, you have what they call wrapper functions. Why? Well, in order to even start with the tree, you need, and of course, the way how the traversal recursive methods are, it passes in the tree node, but you can't just, now you could just get rid of these voids. I was mistaken there. You could just get rid of these wrapper functions and just call print, post order, in order, preorder in your main or your constructor here. But I guess when most examples online, it's just to avoid confusion. But it's pretty much saying, okay, let's call the print preorder, and then what's going to pass through is the tree object reference, which is the start, which is your actual tree itself. But you could just do this. I'll do an example for post order here. You could just call it just like that. But it's just to avoid confusion. It's like, oh, do you want to actually print the post order of the tree traversal? But if you're passing something through, that's going to be a little bit confusing. So just create wrapper functions. You just call it. No input parameters until you actually you're into that method itself. It's just to avoid confusion with the method call, but it'll work the same way. So that is the traversals, the main three traversals: in order, preorder, and post order, and their algorithms for binary search trees on a simple, balanced binary search tree. Thank you guys for watching. Comments down below if you want me to retouch on something or explain something a bit better, and I'll do my best to help you out. Thank you guys for watching. Have a nice day. Okay, so I wanted to touch on something. This has nothing to do with binary search trees, but some of you guys watching may be wondering, well, why does the wrapper function have the same name as the actual recursive method? wouldn't the compiler, or wouldn't Java get confused? No. Why? You can have different methods that have the same method name, but they must have a different signature. What do I mean by that? Well, the return type, of course, they're all void in this case, or, most importantly, the input parameters. The wrapper functions have no input parameters, as we can see here. But within the function, or within the method itself, to actually pass in our tree, the actual start of the tree, into these recursive methods, the Java compiler and many other compilers, even .NET and whatnot, majority of other programming languages, the compilers are going to understand that you're not referring to the wrapper functions, but you're actually referring to the recursive functions because of the method signature. Of course, these are all void in this case, so return type doesn't really play a key role in here. What plays a key role in the method signature in this case is the input parameter of tree node, and the wrapper functions take in no input parameter. So just want to make that clear if anyone has some confusion about that. And yeah, have a nice day.